LangChain Elasticsearch Chat History. A complete description of Elasticsearch Chat Message History class in LangChain. LangChain Elasticsearch Chat History is a class that allows you to store and retrieve chat history from an Elasticsearch index. It is a key component of LangChain which aims to connect various language models and tools in an efficient way. The class provides a mechanism to manage and access past interactions. Component 1. LangChain Elasticsearch Chat History. This component is responsible for interacting with the Elasticsearch index to store and retrieve chat history. It leverages the capabilities of Elasticsearch to maintain a structured and searchable record of past conversations. Component 2. Elasticsearch. This is a powerful open-source search and analytics engine that provides a robust platform for storing and retrieving data. LangChain Elasticsearch Chat History uses Elasticsearch as a backend database to store chat history. It allows efficient querying and retrieval of conversation logs, enabling functionalities like reviewing past interactions and identifying patterns. It uses Elasticsearch as a backend to store chat history. This means that all chat data is stored within the Elasticsearch database, making it accessible for various purposes such as analyzing conversation patterns, extracting insights, and facilitating efficient retrieval of past interactions. It allows you to store chat history in an easily searchable and queryable format. This feature is critical for applications where maintaining a record of conversations is essential, such as customer support chatbots or conversational AI assistants. By storing chat history in a searchable format, it enables users to easily review past interactions, retrieve relevant information, and improve the overall conversational experience. Persistence. The chat history stored in Elasticsearch remains persistent, meaning it is not lost even after the application restarts. This ensures that past interactions are retained and accessible for future reference. Scalability. Elasticsearch is designed to handle large volumes of data efficiently. The scalability of Elasticsearch allows LangChain Elasticsearch Chat History to effectively manage chat history even in scenarios with a high volume of conversations. Search functionality. Elasticsearch provides powerful search capabilities. LangChain Elasticsearch Chat History leverages these capabilities to enable users to easily search and filter chat history based on various criteria, such as date, user ID, or specific keywords. This enhances the ability to retrieve relevant information from past conversations. Requires Elasticsearch to be set up. Elasticsearch is a separate software that needs to be installed and configured. Setting up Elasticsearch can be a technical challenge, requiring some degree of familiarity with the platform. Can be complex to managing an Elasticsearch index, particularly for large-scale applications. Can be complex. Tasks such as index optimization, performance tuning, and security management require specific expertise and effort. Langchainexa Retriever's Exasearch Retriever. A summary of LangChain Exasearch Retriever with explanations. Detailed definition of the variable goes here. Components. Component 1. LangChain Exasearch Retriever is a retrieval component. It enables retrieval of relevant documents from an Exasearch index. For example, suppose you have a large collection of scientific papers indexed in Exasearch. In that case, you can use the LangChain Exasearch Retriever to retrieve papers relevant to a specific research question. Component 2. LangChain Exasearch Retriever utilizes the Exasearch Application Programming Interface API for document retrieval. This retriever is designed to work with the Exasearch API, which offers document indexing and retrieval capabilities. The API provides a standardized way to interact with Exasearch, allowing the langchainexa search retriever to efficiently access and retrieve documents. Description of the architecture supporting the variable. ExaSearch Retriever is built upon the LangChain framework, enabling it to seamlessly integrate with various other components within the LangChain ecosystem. Its integration allows for the retrieval of documents from ExaSearch and their utilization for various purposes such as question answering and summarization. For instance, you could use the ExaSearch Retriever to fetch relevant documents from ExaSearch, which could then be fed into a question answering model to provide insightful answers. Explanation of the variable's role in the system. LangChain ExaSearch Retriever serves as a critical component for retrieving information from ExaSearch indices. This retriever acts as a bridge between the LangChain framework and the ExaSearch platform, enabling the retrieval of relevant documents to power various applications. In a real-world scenario, the ExaSearch Retriever could be integrated into a chatbot that retrieves information from a knowledge base stored in ExaSearch, allowing the chatbot to provide accurate and timely responses to user queries. ExaSearch Retriever efficiently retrieves documents from ExaSearch, ensuring that relevant information is readily available. By leveraging the indexing capabilities of ExaSearch, the retriever can quickly locate and retrieve documents based on user queries, making information retrieval fast and efficient. The retriever's integration with LangChain allows for seamless integration with other components, enabling the holistic approach to natural language processing tasks. The seamless integration allows for a fluid workflow, where the retrieved documents from ExaSearch can be directly processed by other LangChain components, such as language models, for further analysis and tasks. The ExaSearch Retriever, while a powerful tool, depends on the availability of the ExaSearch Application Programming Interface API. If the API is unavailable or inaccessible, the retriever will not function correctly. This dependency on the API highlights the importance of ensuring its reliable operation for the retriever's effectiveness. The retriever's effectiveness is contingent on the quality of the ExaSearch index. A well-structured and comprehensive index is crucial for accurate retrieval. An index that is poorly structured or incomplete may result in irrelevant or incomplete retrieval results, impacting the quality of the information retrieved. LangChain Elasticsearch Vector Stores Exact Retrieval Strategy. NaN. Exact retrieval strategy is a retrieval strategy that retrieves the documents by performing a full-text search in the Elasticsearch index. It uses the query field in the document to perform the search and returns the documents that match the query. For example, you could have a document with the query field "What is the capital of France?" and a document containing the answer "Paris." The exact retrieval strategy would use the query field to search for documents that contain the exact phrase "What is the capital of France?" and return the document containing the answer "Paris." Component 1. The exact retrieval strategy relies on the Elasticsearch index, which stores the embedding vectors of documents. The index is used for efficient retrieval of documents based on similarity search. The Elasticsearch index is used for storing embedding vectors of documents. The embedding vectors are used to represent the semantic meaning of the document. The index is used to efficiently retrieve documents that are similar to the query. Component 2. The retrieval strategy uses the query field in the document to perform the search. It retrieves the documents that match the query based on the contents of the query field. This is important for retrieving documents based on specific keywords or phrases. The exact retrieval strategy architecture consists of Elasticsearch index for storing embedding vectors, A query mechanism that uses the query field to search for matching documents. The Elasticsearch index is used for storing embedding vectors of documents. The query mechanism is used for retrieving documents that match the query. The exact retrieval strategy is used to retrieve documents from the Elasticsearch index. It provides a mechanism for retrieving documents based on full text search using the query field. This is useful for retrieving documents based on specific keywords or phrases. Advantage 1. Exact retrieval strategy provides efficient retrieval of documents based on full text search. It retrieves documents that match the query based on the contents of the query field. This makes it a fast and reliable method for retrieving documents. Advantage 2. It can be used for retrieving documents based on keywords or phrases present in the query field. For example, you could use the exact retrieval strategy to retrieve documents that contain the keyword France or the phrase capital of France. Challenge 1. Exact retrieval strategy does not consider the semantic similarity of documents. It relies on exact matches to the query in the query field. This means that the retrieval strategy will only return documents that contain the exact phrase in the query field. For example, if the query is "What is the capital of France?", the exact retrieval strategy will only return documents that contain the exact phrase "What is the capital of France?". It will not return documents that contain the phrase "Paris is the capital of France". Challenge 2. If the query field is not comprehensive or lacks relevant information, the retrieval accuracy can be limited. For example, if the query is France and the document only contains the phrase "Paris is the capital of France", the exact retrieval strategy will not return the document. This is because the query field does not contain the exact phrase "Paris is the capital of France". To address this challenge, you may need to use a different retrieval strategy that considers semantic similarity, such as the embedding similarity search retrieval strategy. Ensuring consistency and reproducibility of retrieval results is crucial for reliable and predictable outputs. Challenge 13. Monitoring the performance of the retrieval system over time enables identifying potential issues and areas for optimization. LangChain Elasticsearch Vector Stores Sparse Retrieval Strategy. An explanation of the LangChain Elasticsearch Vector Stores Sparse Retrieval Strategy is a strategy for retrieving relevant documents from an Elasticsearch index using vector similarity search. A retrieval strategy that utilizes vector similarity search in Elasticsearch to find the most relevant documents. Components. Component 1. A powerful open source framework for building and deploying language models, agents, and applications. LangChain provides a modular and flexible architecture for interacting with various language models and integrating them into applications. Component 2. A popular open source search and analytics engine that provides a highly scalable and robust platform for indexing and querying large datasets. Elasticsearch uses a distributed architecture and supports a wide range of data types and indexing capabilities. Component 3. A technique for finding similar items in a dataset by comparing their vector representations. Vectors are mathematical representations of data points, allowing for efficient similarity calculations. Vector similarity search is commonly used in various applications, including recommendation systems, search engines, and image recognition. A LangChain-based system leverages Elasticsearch for efficient vector similarity search and document retrieval. Role. The sparse retrieval strategy employs vector similarity search to identify the most relevant documents for a given query from an Elasticsearch index. Advantages. The sparse retrieval strategy efficiently retrieves relevant documents by utilizing vector similarity search, which allows for fast and accurate identification of documents based on their semantic content. This strategy leverages existing Elasticsearch infrastructure, reducing the need for additional setup and resources. Organizations already using Elasticsearch can easily integrate the sparse retrieval strategy into their existing workflows without significant changes to their infrastructure. Challenges. To leverage vector similarity search, it is essential to pre-embed documents and index them in Elasticsearch. This pre-processing step involves transforming documents into vector representations and storing them in the Elasticsearch index. Fine-tuning search parameters can be necessary to optimize results and achieve the desired level of accuracy and relevance. This involves adjusting settings such as vector similarity metrics, search algorithms, and index configurations to match specific requirements.